we're lucky today. Excited, as I mentioned, that Kisharu from NCI is able to join us, and he's going to demo the work he's been doing around flows. If I was able to show my slides, I would have shown some of the that I actually went back into the introduction for about a year ago, where we sort of highlighted some of the issues around the bottlenecks with transfers and sort of orchestrating those workflows, and been really keen to see that area take off with the work that's going on here now. So very excited to hand over to Kisharu and get him to run with his demonstration.
Sure. Thanks, Greg. I'll start. I'll try to share my screen. I hope you all can see it.
I hope you
All
got
good?
more luck than I had.
Cool. So yeah, I'm Kisaru Liyanage, as Greg introduced. So I'm an HPC specialist working on health and life sciences project here at NCI Australia. And I'm also joined by Matthew Downton. He's the Associate Director of Performance Optimization team here at NCI Australia. So I'll be presenting our work on using Globus Flows on Gadi. So the Gadi is the high performance computing system we have at NCI. And I'll first be talking through the key points, and then I'll move on to a demo which shows how this works in practice. So we explored how we can use Globus Flows for automating bioinformatics workflows. Now, when it comes to bioinformatic workflows, they often require large data transfers followed by workflow execution. And the traditional approach to do this is to first manually initiate and monitor the data transfers, and then manually launch the workflows after data arrival. And as you can imagine, this is prone to delays and human error. So we've come up with an improved approach with Globus Flows. Now we use the Globus transfer component in Globus to automate reliable data transfers. And then we use the Globus compute component in Globus to automatically trigger and monitor the downstream workflows. And this finally enables faster, reproducible, and fully automated workflows. So I'll talk a bit about the Globus flow design that we've come up with. So we actually tried this with two approaches. The first approach was to first do the data transfer and then launch the workflow directly on Gadi within what we call a persistent session. So these persistent sessions are designed to support long running, low memory, low CPU intensive tasks here in Gadi. So we in the first approach, we do the data transfer and then launch the workflow directly on a persistent session on Gadi. And then the second approach is we do the data transfer first, similar to before, and then we launch the workflow on Secura platform. Now, the Secura platform, the workflows that we launch in this example is there are Nextflow workflows. So Nextflow is a workflow management system, and then Secura platform is a platform that allows you to run these Nextflow workflows on a backend platform like a HPC cluster. And then also it has this nice feature to monitor the status of the workflow using a nice user-friendly user interface. So that is why we used Secura platform in the second approach, and that I think is a bit more advanced approach. So that will be what we'll be demoing today as well. And the slide shows the main 4 stages in the Globus flow that we've come up with. The first stage is called set constants, and that stage is used to initialize constants like the Globus collection IDs and then Globus compute endpoint IDs. And then once that is done, it transitions to the next stage, which is data transfer stage. And that is the stage that performs the actual data transfer. So it transfers the input from a source Globus collection to a Globus collection set up on Gadi. So for that, we use the Globus transfer component. And then the next stage in the flow is launch workflow. And this stage launches the workflow on Secura platform. And for that, we use a Globus compute function, actually. So the final stage of the flow is monitor workflow, and that polls the status of the workflow until its completion. And for that, again, we use Globus compute. So that's the basic design. And then we can talk a bit about the system architecture. So here I've listed the main components involved. So we have a Globus flow, of course. And for the flow, we have the flow definition, and then we have the input schema. So this schema is used to create a user-friendly form to take the inputs to the Globus flow. And then we have the Globus collections. So they are the ones that are used to do the data transfer. And then we have a Globus compute endpoint, and then also compute functions that are going to be running on the Globus compute endpoint. And then we have the Secura Tower agent. So this is optional, as in only if you use that second approach, you need the Secura Tower agent. So this diagram shows how these components are interconnected. I have my laptop, and that is set up with a Globus collection. So that is going to be the source data source. And then we have the Globus service on the cloud, and the Globus flow is registered there on the Globus cloud service. And then also the compute functions are registered there. And then we have the Secura cloud. And then we have the Gadi supercomputer. So this is where the heavy lifting happens, actually. And then on Gadi, we have the Globus collection. This is where the data will be copied to. And then we have a persistence session, like I briefly talked to you about earlier. So they are there to support long-running, low-memory, low CPU jobs. And so within a persistence session, we have a Globus compute endpoint running within a persistence session. And also in parallel, we have the Secura Tower agent running. So this is used to talk to the Secura cloud. So when you start the Globus flow, it first starts with the set constant stage, and that initializes the constants like the collection IDs and endpoint IDs. And then it transitions to the data transfer stage. And in that stage, it moves the data or transfers the data from the source called Globus collection set up on laptop to the Globus collection set up on Gadi. And then once it's complete, the flow transitions to the next stage, the launch workflow stage. And there it actually runs. So we have a compute function written to launch this workflow on Secura Cloud. So that function gets run on the compute endpoint, which is running again within this persistent session. And what that compute function essentially does is that it talks to the Secura Cloud again via an API call. So Secura has a API. So we use the Secura APIs to talk to the Secura Cloud and then get the workflow launched. So once that's done, it transitions to the final stage, which is monitor workflow. That again is very similar to the previous stage, as in we have a compute function defined for that as well, Globus compute function. So that again gets run on the Globus compute endpoint, and this time it uses the Secura API to poll the status of the workflow. So when it sees the status other than running, it returns from the compute function, and then that is going to be the end of the Globus flow as well. So that's that. And I think we can now move on to the demo. So this is a live demo, and I hope everything will go smoothly. So I have the Globus Flow loaded up here, and then I'll start the Globus Flow. So this is the interface used to take the inputs to the Globus Flow. I'm gonna use the source collection from here, named it KXL laptop. And from here, I'm gonna choose the input data files. So these are the input files to the workflow. So I basically chose the folder that contains all the input data corresponding to the Nextflow workflow. And then we have the next input parameter, which specifies the input destination. And this is the path on Gadi collection where the input data will be copied to. So, and then there's a parameter to take in the workflow params file. So with this Nextflow workflows, usually we have a parameters file that defines all the parameters required to run the workflow. So that parameters file, the path of the parameters file, we specify that here. So this actually is transferred along with the input data files, and this is going to be the expected path of that parameters file. And then we have a workflow work directory. So this is the location of the directory that is used for as the working directory for the workflow. Then we can give a label to the flow run, and then we can start the run. Go into the run details. If you check the event log, we should be able to see what's going on. So it's already gone through the set constant stage, and it's now in the transfer stage, data transfer stage. This hopefully should not take too long because the data files are around 300 megabytes. Okay, so it's already done with the transfer as well. So we should be able to see that data transfer completed here. And then it's now started the launch workflow stage as well. So it took only 37 seconds to do the data transfer. And I can show you the Sekera UI. So this is the Sekera UI. Once the workflow gets launched on the Sekera platform, we should be able to see that listed here, appearing here. So started the stage, but I think it has not finished. Oh yeah, now it's done. So we can see it's now here. So it's submitted just now. And then we can, the nice thing about Sekera is that you can see the status of the workflow with a nice UI. So it's just started, and once the subtasks corresponding to the workflow get submitted to the cluster, we should be able to see them listed up here. So when you start a Nextflow workflow with Sekera, it's actually going to launch a head job on the cluster. And then that head job is going to spawn child jobs, the subtasks. We should, I think, be able to see that here. So qstat, if we do a qstat here, I can see the status of the jobs that I have submitted to the cluster. And this is the head job corresponding to the workflow. And when the workflow starts submitting the subtasks, we should see them here as well as here.
While you're walking us through that, we've got one question that's popped up in the chat.
The jobs are submitted. So yeah, there's a Globus user, and then also so the jobs are actually submitted as as the local Gadi uses. So the compute endpoint actually is going to execute this compute function, right? So from the compute function, we launch the workflow, and then we talk to the Sekira API again there, and then Sekira API is going to talk back to back to Gadi, and then whatever the user that you have logged in on the compute endpoint, that user is going to be the one that is submitting the jobs to Gadi as well. That's the user. So in this case, I have logged myself here, and that is not a Globus user. So there's a separate, and it's not some Globus user. I hope I answered your question.
So is it fair to say that the user is determined by whoever you authenticated with Sequera as is that? So when Sequera kicks off the job, it runs as you, does it?
Yes. All right. So we see 2 jobs being submitted here, and 8 have already succeeded. And then we can see that here as well. So the 2 submitted jobs we can see here. Workflow, and then it's now run for 6 minutes, and all these details you can see with the Sekera user interface. That is a nice thing about Sekera. And then since we got a bit more time, I'll try to go through the code for the flow as well, briefly. And then the flow schema and the compute functions as well. So it's got the 4 stages, and in the first stage, it is a set constant stage, and that sets up the IDs. So destination Gadi collection ID, the compute endpoint ID, and things like that. The constant values are set up here. And then we have next we have the transfer to compute endpoint stage, which performs the data transfer. So for that, we use the transfer API of Globus. And then for that, the inputs are going to be the input source and the input source and the input destination. So the source is taken from user input, and then the destination actually is always constant because it's going to be the collection set up on Gadi. So it's taken from the constants. And then we have the launch workflow stage, and this is where we use the Globus compute service. So compute endpoint ID, we take it as a parameter, and then the function UIDs. UIDs again, we take the function UID of the launch workflow function as a parameter, and then also the other input parameters to the function also can give here. And then we have the monitor workflow stage. There we use again the Globus compute service, and these compute functions are actually only doing API calls to Sekera platform. So they are very lightweight functions. So to this monitor workflow function, we have to take in as an input the workflow ID. So that ID actually is coming as a result from the launch workflow stage. So launch workflow stage is going to launch the compute function that is run within the launch workflow stage is going to return the workflow ID of the workflow that was just launched, and then that is passed on to the monitor workflow function. And that's that. Then we had a flow schema. That's again a simple schema because input source we take in, and then the destination, input destination, and then workflow params file. Those are just string inputs. So that's the flow schema. Then we can have a brief look at the compute functions as well. So this is the this is that launch workflow function I was talking about earlier. So what we do there is making an API call to the Sekira platform. So we have the API base, and then now talk to the Sekira API. You have to use a Sekira API access token. We actually set that API access token in the environment, and then within the function, within the compute function, we check for that environment variable and then get that from there. And then the other inputs. Yeah. So, and then this is where we set the headers for the API request. And this is where we set the JSON payload for the API request. So it contains the compute environment, Sekira compute environment ID, and then the path of the workflow, next to workflow and things like that. All the input parameters required to get it launched on the Sekira platform. And then this is where we perform the actual API call. And this is where we check the status of the response from the API call. So yeah, if the API call was successful, I think if the launch was successful, we are going to get the workflow ID returned. And if that is available, we return it from the compute function. And then if that was not found, that is going to raise a Python exception. And this is for the error handling. If the response.ok was not present at all, we are again going to raise an exception. And this is the monitor workflow function, compute function. And that's again very similar to the previous one, because we are again making API calls to the Sekira platform, Sekira cloud. And then we have this poll interval set here to 5 minutes. And then again, use the Sekira API access token, and then setting the headers. And we have an infinite loop, and every 5 minutes we make an API request, API call to check the status of the workflow. So we use this workflow ID that was passed on to the function to make this API call. And if this is where we pass the response, and if the status is succeeded, then we can safely break from the loop, and that's going to return from the function as well. And then that will be the end of the Globus flow as well. If it was one of these states, that means something has gone wrong with the workflow, that we are raising an exception here. And this is for the error handling. So yeah, that's that. And then this is the code that we use to register these two functions on the Globus service. Yeah, that's pretty much it about the code. You can see what's going on here. So it's still submitting jobs, and this I think is going to take close to 30 minutes to complete. And once that is complete, we're going to see that here as well, and that will be the end of the Globus flow.
And so how many jobs is it submitting?
Sorry?
How many jobs is it submitting to Gadi as it's as
that I cannot actually, to be honest, remember, but I think I have a successful run for this one. Oh yeah, 145 jobs at the end. It'll submit to the Gadi.
So there's one question from Lev in the chat. Is Gadi compute endpoint a single user endpoint installed by each user for themselves, or is it a multi-user endpoint installed centrally by Gadi admins?
This is a single user endpoint actually that I use for this purpose. It is not a multi-user endpoint. So each user has to start the endpoint. We can sorry.
And the endpoint has to be basically a job on the cluster, right?
No, in this case, we actually, like I said, we have this this thing called persistent sessions. So you can run it's not a cluster job, to be honest. It's you can just run a command with it. Like that's more like a VM instance. You can think of it as a VM instance, but you can only run low resource intensive things there. Yeah.
Okay, thanks, Kisharu. That's fantastic. We might
Okay.
sort of we can come back to that, but we'll throw it open to the office hours session just to see if there's any further questions for Kisharu or any of the Globus team that are joining us today.
I keep pushing on the endpoint front. I think you might benefit from doing, if you can install the multi-user compute endpoint, then that would make life a lot easier for the users, because now they don't have to have the persistent session, because the multi-user endpoint will take care of it automatically.
Yeah. True. So this actually we did more like a proof of concept idea, proof of concept thing. So yeah, for the production thing, it'll be useful to have, like it'll make more sense to have that multi-user endpoint. In that case, the user doesn't have to manage all that themselves. Yeah.
Right, and since you already have a transfer endpoint, so you already have the identity mapping in place, you can just use that very same identity mapping for the multi-user compute endpoint, and it'll be very straightforward.